So I figured we would take the distributive property and relate it to factoring. So when we do it in this direction, it's called factoring. An example would be like 2x squared plus 9x minus 5. So in algebra, you're going to need to learn how to factor these quadratic form polynomials. So let's look at how to do that. So when I was a kid, the way I would do this is I would just start guessing for, what goes here, and what goes out front here and here. That can take forever. Sometimes you'll guess right, but depending on the number that's out here in front and the number at the end, it can take forever. So a really quick way to do this is to break up the middle term into two pieces that are being added together. And we want this second term to share a factor with -5, and the first term to share a factor with 2x squared. So the way to guarantee this is just to take the coefficient on the first and multiply the coefficient on the last, or the last coefficient. So 2 times -5 is -10. So one condition that we have, or condition number 1, is that our product is -10, and then the other one we talked about was that the sum needs to be +9. So what two numbers have a product that is -10 and a sum that is +9? And it's maybe plain to see that those two numbers are +10 and -1. They add to +9 and their product is -10. So we've satisfied both conditions. So let's go to the next page. So what I've done here is I've rewritten what we had on the previous page of 2x squared plus 9x minus 5 to 2x squared plus 10x minus x minus 5. So nothing's really changed. But what we've done is we've created a common factor here in the first two and the second two. First pair and the second pair. So notice that 2x squared is 2x times x, and then 10x is 2x times 5. So this looks like the distributive property, right? That we talked about on the first page. So I can factor out the 2x out front. So we get 2x times x plus 5 out of the first pair. And then similarly, in the second pair, I can factor out a -1 out of both. So I get 2x times x plus 5 quantity minus x plus 5 quantity. So this looks again like another distributive property factorization. So these parentheses these parentheses are important to remember because you want to treat each the x plus 5 as a unit unto itself. So anyways, we said this looked like a distributive property factorization. So I can pull the x plus 5 out front and I'll get 2x left in the first, and then x plus 5, or negative x plus 5 quantity over x plus 5 quantity is just negative 1. Remember, we have to put our parentheses on that. Excuse me, x plus 5. So the polynomial factors into x plus 5 quantity times 2x minus 1 quantity.